In this video, we will talk about hydrocarbons and some of the basic information about it. We want to explain what the IUPAC is and its relation with hydrocarbons. We also want to explain about the different hydrocarbons, like the alkanes, alkenes, alkynes, and aromatics. What we want to explain about these hydrocarbons is how to name them and structurize them, as well as the derivatives of hydrocarbons.
The UPAC is a system to determine what is the name of the alkynes are. The hydrocarbons are organic compounds made entirely by hydrogens and carbons. Classification of hydrocarbons are alkanes, alkenes, alkynes, and aromatics.
Alkane is a saturated hydrocarbon. Alkanes consist only of hydrogen and carbon atoms, and all bonds are single bonds. The steps to name an alkane based on the IUPAC system are: draw your molecule, number the carbons on the parent chain, and assemble the name in alphabetic order. An example will be pentane. Pentane is a linear straight chain alkane and has 5 carbons atoms, so N equals 5. We therefore use this general chemical formula for alkane. Here C sub NH sub N plus 1. Example 2. Cyclobutane. Cyclobutane is a cyclic alkane and it has 4 carbons atoms, so N equals 4. The 4 carbon atoms are bonded to each other, making one ring. Here we use the general formula for cyclic alkane, C sub NH sub 2 times N plus 1. Cyclobutane can be drawn 2 ways. On the left we see that it shows all the carbon and hydrogen atoms, and on the right, cyclobutane can be drawn as a square where the hydrogen atoms are not shown, and each edge of the square represents carbon atoms. In the chemical structure, we have a ring, so G equals 1. The double bond is shared by the 2 carbon atoms and does not involve the hydrogen atoms, although the condensed formula does not make this point obvious. Note that the molecule formula for ethene is C2H4, where areas that for ethane is C2H.
Step to name the alkyne are identified to the longest chain. Number from the end closest to the first branch. Name the groups attached to the chain using the carbon numbers as a locator. Combine number and name of the substituent with parent name separating with hydrogen. CH3 of CH3, this hydrocarbon is classified as alkyne and its name ethane because it has 2 carbons.
Alkynes are molecular compounds made out of carbon and hydrogen. The special thing about alkynes is that they have triple bonds between each carbon. You determine how many and between which carbon of the line. Now, the prefixes of alkynes are the same as alkenes and alkanes. The difference is in the suffix, which is Y, N, and E. By this way you can tell if it has one bond, a single bond, a double bond, or a triple bond. If it has Y and E, it has a triple bond. The way to write this type of compounds in a formula is quite different from the alkanes, because alkanes are in a horizontal way. This one starts with a diagonal way and continue its way down or up, depends on if it has trans or cis.
An aromatic hydrocarbon is a hydrocarbon that contains one or more benzene rings that are characteristic of the benzene series of organic compounds. To name aromatic based on the IUPACs, you just have to follow these steps. For substituted benzene rings, where the substituent contains more than 6 carbons, the benzene ring is noted by using a phenyl prefix on the alkane name. For substituent benzene rings, where a substituent contains less than 6 carbons, the alkyl chain is added as a prefix with the ending changed to YL. For benzene rings with multiple substituents, the ring atoms are numbered to minimize the numbering of the substituent groups. Alternatively, ortho, meta, para nomenclature can be used for the substituent rings. Ortho, a prefix used to name an aromatic ring with two adjacent substituents. Para, a prefix used to name an aromatic ring with 2 substituents directly across from one another on the ring. Meta, a prefix used to name an aromatic ring with 2 substituents separated by 1 carbon on the ring. Here are some of the name of aromatic compounds in its common name, then changed into IUPAC. Toluene is going to change into methylbenzene. Orthosilene, it's going to be changed into dimethylbenzene. Metasilene, it's going to be changed into dimethylbenzene. And paraxylene, it's going to be changed into dimethylbenzene. The most commonly encountered aromatic compound is benzene. The usual structural representation for benzene is a 6-carbon ring, represented by a hexagon, which includes 3 double bonds. Each of the carbon represented by a corner is also bonded to one other atom. In benzene itself, these atoms are hydrogens. The double bonds are separated by single bonds, so we recognize the arrangement as involving conjugated double bonds. An alternative symbol uses a circle inside the hexagon to represent a 6 pi electrons. It's possible to name your benzene molecule as you would any other cyclic hydrocarbon, starting alphabetically with the first substituent and assigning numbers going around. However, there are some special designations for substituents positions in benzene molecules. Ortho, or O, the 2 substituents are located at 1 and 2. Meta, or M, the 2 substituents are located at 1 and 3. Para, or P, the 2 substituents are located at 1 and 4. In the following examples, the first row of compounds show this usage in red. These substituent toluenes have singular names and their isomers are normally designated by the ortho, meta, or para prefix. A few these substituted benzenes have singular names given to specific isomers. Finally, if there are 3 or more substituent groups, the ring is numbered in such a way as to assign the substituent the lowest possible numbers, as illustrated by the last row of examples. The substituents are listed alphabetically in the final name. If the substitution is symmetrical, the numbering corresponds to the alphabetical order.
Hydrocarbon derivatives are molecular compounds of carbon and at least one other element that is not hydrogen.